Good morning, everyone. I sent a handful of you some messages quick on the chat. I just want to make sure that you see that and you respond to it. It was mostly about either finishing, I should say, starting the Chapter 4 test, or you finished it and you did not submit your worked out solutions to Schoology. So remember, those worked out solutions were worth 7 out of the total 50 points on your test. So please make sure that you submit that. Otherwise, you lose the 7 points. Okay, our goal today is to review some ideas centered around factoring and around simplifying fractions. So we're going to start, some of this is real quick review of fraction work that you learned a long time ago. And we're going to start with what's our rule for subtracting fractions? And actually, in this case, it's adding the opposite, because if this is negative and that's negative, that turns into addition. But what's my rule for adding or subtracting fractions? You need the common denominator. So I got to figure out what's the least common factor of that 5 and 8 both go into. Quick way to do that is multiply the top by 8. Now keep in mind that's a negative, not a divide sign. And then we're going to multiply by 5, so I get 48, and I'm going to count that as negative 48 because the negative sign, over 40 plus 15 over 40. And then now that I have my like term, this is a skill that you can basically skip. But that's what we're doing. We're adding the numerators and we're keeping the denominator the same. And when I go ahead and do that, I get negative 33 over 40. And that does not reduce, so that's as far as we can go. Okay? Now, number 2 is almost the same thing, except for it's with x's and y's, and that's kind of where we're headed, is can you follow the rules that we've learned in the past and apply them to new features? Maybe they have x's and y's. Pretty soon we're going to put cosines, sines, tangents, secants. So hopefully you're going to see the connection as to why we're reviewing this later on today. Well, I have a fraction plus a number, technically. I want to think of this as a fraction times a fraction. And my rule for adding fractions is I need the same denominator. So this one needs a denominator of y, and the only way to get that is to multiply the top and bottom by y. All right? So what I'm going to do then is, if you want to rewrite this, you can. But I've got x times y times y. Well, that turns into x times y squared over y. And now I can go ahead and add, just like I did here, 1 plus x times y squared all over y. And that's as far as we can really simplify this. Okay? But we just turned it into a single simplified expression. This is just one fraction now. This one always tends to get kids. So the way I like to think of it as I've got negative 1/2 divided by, I usually make this sign really big, divided by negative 3. Well, I don't like to divide a fraction by a number. I like to think of this as a fraction divided by a fraction. So what we have to do then is our rule for dividing fractions is we don't divide, but we multiply by the reciprocal. So that's why I put this over 1, is because now I'm going to multiply by the reciprocal. And when I multiply fractions, we just multiply numerator times numerator, denominator times denominator, and then simplify, and a negative divided by a negative is a positive. All right? Now this one, it's already combined together, so all we have to do is reduce, and there's a couple ways to think of this. I think of it first as the fraction of 7 over 11, and that fraction cannot be reduced, so I know part of my answer is going to be 7/11ths. And then we deal with the x's. Now, officially, the rule of exponents that we have here says if you have the same base, you're allowed to take the exponents, the one in the numerator minus the one in the denominator, and you end up with x to the negative first power. Now, if I wrote that, that would be written off to the side But we also know that if it's a negative, we actually prefer to write that negative down below. So my final answer would be 7 up top over 11 times x. You don't really need the 1 here. Now, to be honest, what I would do is I'd skip all this extra work, and I'd say, I've got one more x on bottom, and x on top is going to reduce out, and that's going to reduce out with one of the x squareds. So then I just have one x on bottom. So there's multiple ways to think of this. And number 5 then is a combination of number 3 and number 4. We have a fraction divided by a fraction, right? So I'm going to make this big divide bar so I know the numerator divided by the denominator. And my rule is we don't like to divide by a fraction, right? We change this to multiplying by the reciprocal. So I'm going to flip those around. And then technically I could multiply across. However, one of the things that I've noticed is if I'm going to multiply straight across anyways, I've got some factors that could reduce out. Like think of this 4 and this 8, they share a common factor. So I'm going to take away a factor of 4. So that's going to leave me with a 1 and a 2. 5 and 7 don't have any common factors, but I have x squared and I have x to the third. So I've got x times x on top and x times x times x on bottom. These x squareds are going to go away, and it's going to reduce out the third and leave me just with a 1. So now I'm thinking, well, what's left on top? I've got 1 times 5, and we multiply because that's what we're doing. So I get 5. And then I get 7 times 2, well, that's 14. And then there's a single x, and x to the first power left over. Okay? And that's not the only way to do this. I do want you to keep that in mind, right? So hopefully all of this was a review. Technically, it's what you did in Algebra 1. And the question you might be asking yourself today is, why are we learning this? Well, I teach calculus, and one of the things I found is that my students coming into calculus really struggle with the idea of fractions and how to deal with fractions as we think about it. So that's where we're headed today. Just kind of a quick review. We're going to do some breakout rooms in a second. But our goal today is to use factoring and fractions to simplify expressions. So good news is you're not going to take a lot of notes today. You're going to have basically 2 slips that you're going to work on in your breakout rooms. Now, this might be something you want to go back and look at in the notes. I'm not going to give you time right now to write it all down. But if you want to do a screenshot of it right now, you can. But we're going to talk about the rules of factoring. All right, so when I factor, I have adding and subtracting. They have the same rule. You need the common denominators before you can add or subtract. Okay, and then there's a little bit more to the rule if you want to think of it. You need a common denominator. Then once you have that common denominator, you add the tops and the bottoms stay the same. So you add the numerators, denominators stay the same, which is the idea of the common denominator. Same thing for subtraction, except for you subtract the tops. Okay, multiplying by fractions, you just multiply straight across, numerator times numerator, denominator times denominator. And then the big one is the one that I think a lot of students tend to forget is dividing fractions. Change it. We want to change it to multiplying by the reciprocal, and then you follow the rule for multiplying fractions. So we reviewed all of these in the warm-up, and I want to show you a couple more here. Do not write this, because we're going to go fairly quick over it, and our goal is to really get you to focus on understanding what that means when you have fractions. So what we did was we created kind of some crazier problems that aren't really numeric based, but your goal here is if you have a can divided by 3 pen plus 2 over 5 can, you can still add those together. Our rule is we need a common denominator. So I got to think of the word can as a variable, right? And the word pen is a variable. And then I need to get the same denominator. So I want to think, okay, well, what does this denominator need that this one has? It has a can. So I'm going to multiply the top and the bottom by the word can. but it also needs a 5. So I'm going to actually multiply it by a 5 as well. I don't have a ton of space here, so I'm going to multiply that by 5. And you're going to see, what do we get then? I get 5 times can times can. So this will be 5 can squared on top over 5 times 3 is 15. And then if I have can and pen, we kind of write it in alphabetical order, but there's no official wrong way to write that. So my denominator for this first one is 15 can pen. Sounds weird, right? But this is hopefully to get us to help understand what common denominators are. So then I'm looking at this one, and it needs to basically be the same. So it has a 5. Well, I need a 3 there. So I'm going to multiply the top and bottom. That'll give me 15. I already have can, but I need a pen on this side and this side. So then I've got, on the bottom, I've got 15 can pen. Those are the same. And up top, I have 3 times 2, which is 6, pen. Well, now I can add the fractions together. So I've got 5 can squared plus 6 pen, and those are not like terms, so I can't combine them. But I'm going to keep them over the same denominator. And then I want to think just kind of quickly, since I have new numbers up here, 5, 6, and 15. There is nothing that goes into 5, 6, and 15 other than the number 1, so I can't reduce all of that out. Okay, let's try this one. Here I've got star divided by 3 minus circle over star times heart. And if I'm going to subtract them, I need the same denominator. So what do I need over here? I need a star and I need a heart. And if I multiply the bottom, I have to multiply the top. And then over here, I have the star and the heart, but I need a 3. So what do I get? I get star times star. So I can go star squared times heart. And you could write that as heart times star squared as well. And we usually write the numbers in front. And then I get 3 times the circle over 3 star heart. And you can see that the denominator is now the same, so I can keep the denominator. And then up top, we're just going to write star heart minus 3 times the circle. Okay, and don't judge me on my heart and star ability drawing skills. I'm going to make this look more like a 0 than a 3, or excuse me, a 0 than a 30. All right. So, what about multiplying? Right? What if I take the same thing, but now I tell you to multiply or divide? How do we approach this? Well, the same rules. With multiplication, we multiply straight across. However, if you have a common factor on top and on bottom, see how I have a can on top and a can on bottom? Since we're going to be multiplying these anyways, some people like to write this, but I'm going to show you what I do just to make it easier. If I multiply the bottom, 3 times 5 is 15. Pen times can is just pecan, pen can. But notice, you would have this reduce out anyways, right? I got a can on top and a can on bottom. Well, instead of writing this, why not reduce the can first? That's what I would say. So if you reduce the can first, then what's left over on top is just 2. On bottom, you got the 3 times the 5, which is 15. And 2 over 15 cannot reduce. And then pen remains on the bottom. So you can skip this middle step if you reduce factors right away. All right, how would we do this last one? We've got star over 3 divided by, well, we don't like division, right? We don't like to divide fractions, so we're going to change that to multiply by the reciprocal. Notice I'm only flipping the second fraction. The first one stays exactly the way it is. And now, if there's anything that reduces out, we would do that, but I have star, star, and heart up top, and I've got 3 and circle on bottom. So then I just multiply straight across, because nothing reduces out. Star times star is star squared. Part over 3 times circle. And if you want, you can put the little dots there, or you can just leave them. Okay? So, I know it sounds a little weird, but our thought is if we just don't do this with numbers, you're going to be able to kind of focus on the meaning and understanding the rules. And the other thing is, you can't just plug it into your calculator, because that's what we don't want. So here's what we're going to do. We're going to go into a breakout room for about 10 minutes, and you're going to have, I'm going to send you this link here, but you're going to have a sheet that looks like this. All right, and on this sheet, you will, oh, I got to get my link. You just have to answer problems 1 through 10. Now, the first couple are just numbers. Please do not use your calculator to get the answer. What we want is we want you to just simplify without a calculator, and then 5, 6, 7, all the way down, those are dealing with words. Okay, so if you go to the chat, I'm going to send this to you, and then we're going to put you in breakout rooms of about 3 or 4 people, so you guys can talk through this, compare answers. After about 10 minutes, maybe a little bit longer, I'll message you and say you have a minute left, and then we'll come back and we'll go over the answers to this. So we're going to go 8 breakout rooms. So you can join the breakout room as soon as you open the link. And then just write this work on a separate sheet of paper. You don't have to write down, just write your answers and the work that you need to show. All right, you should be able to join your breakout rooms now. So hopefully you had a chance to kind of work through some of this with your peers. If you happen to be watching this video at a later time, make sure you pause and do these problems and then check your answers here. I apologize for kind of the faintness of this print. It's the best I could get. I'm not going to go through every one. I just want you to check your answers here. So number 1, you should have got 23/15, and the common denominator was 15. Number 2, I don't know if you like the way that I did this, but I broke down 8 as 2 times 4, and I broke down 12 as 4 times 3. And then I realized that this just needs a factor of 3. This one needed a factor of 2, and that gave me my common denominator of 24. There's multiple ways to think about that and do that, but you should have got 23/24. With number 3, multiplying, you just multiply straight across, so you get 36/125. That does not reduce. Number 4, we're flipping, so I rewrote this first, and then I times by the reciprocal 5/3. And then you'll notice what I did. I factored 12 and I factored 25, and I decided let's reduce right away. You don't have to do this, but I think it's easier. Is a factor of 3 can cancel out top and bottom, and a factor of 5 can cancel out top and bottom. And the nice thing there is you get 4/5, which is already reduced. All right, number 5. We already have the same denominators, so you're just adding 1 snow plus 2 snows, which equals 3 snows over yellow. And then number 6, we've got 4 caret minus 4 blue. Well, I need a blue in this denominator and a caret in this denominator, so we're going to multiply top and bottom. That leaves me with blue lime minus brown caret. Sounds delicious, doesn't it? Over 4 blue caret, and there is no common factors between blue lime and brown caret, so I cannot reduce this at all. All right, and then here, before I multiply, notice what I did. I canceled out common factors, because if I'm multiplying for number 7, we're going to multiply straight across. So if I have a plum factor up top over here and a plum in the denominator, those plums are going to cancel out. And I have one leaf is going to reduce out with one of the leaves for the squared. And then a factor of 2 is going to reduce out of 6. So what's left over is apple times leaf up top. And the entire denominator reduces out except for the 3. So I get apple times leaf over 3. And then we get plum times apple divided by, so you'll notice what I did, I ended up actually rewriting this. I flipped this so we're multiplying by the reciprocal, and then you can see that the nothing reduces out, so you're just going to multiply straight across. All right, and then 9 and 10 I had to rewrite up here. This is more like what you're going to see. We're not going to do real words, but we've got variables, and the words are basically the same thing as a variable. So when I do this, I notice that I get, I have a 4 over on this side, 4a. Well, this needs a b on the left side, and I need a 4 on the right side to get the same denominators. So multiply the right by b, the left by 4, and then I've got the same denominators and I can add. Now notice alphabetically, I just put these in order, so 5b came first. If you wrote 8c plus 5b, it's the same thing. And then down here, this last one, it's just multiplication. Well, I could have reduced an x out here and here right away. I decided to just multiply straight across in this one, so I could show you that the x on top and bottom reduce out. And you got 12 over 5 wy. So nothing, I mean, maybe something super crazy there because we haven't done a lot of this, but it really focuses on the rules. All right, so the next thing I want to just quickly brush over is factoring. Factoring is a skill that in every math class, you will have to know and do factoring. So I want to go through just a couple of quick problems and just kind of remember what you're doing. We started learning the distributive property. If I have 2y plus 3 and I distribute the 2, then I expand that, right? So you get 2y plus 6. But undoing the distributive property is the idea of factoring. And that's what we're looking at here, is when it says factor the expression, we're looking for taking a common value. What's common between 2 and 6? We took out a 2, right? Now that 2 didn't disappear, but it was rewritten on the outside. So we're doing the same thing here. I want to take out the most common thing from this term and this term. Well, that is a y to the 4th. And then what's left over is x minus 1. Now notice, because I take a y to the 4th away, it doesn't mean this goes away, right? It means there has to be something there. It's a placeholder of 1. Now here's the best thing, is once you get your answer, you can expand it. So if I was to distribute this, you should get back where you started. Okay? And then you should always check to see if you can factor this part any further, and the answer here is no. Okay, then we're going to look at this one, and we're going to see what do they have in common. Well, I've got a 45 and a 9. So if I factor a 9 out right away, that'll leave me with a 5 and a 1. Right? If I take 9 away from 9, there's technically a factor of 1 left over. Some people like to think of it like this. And then you can see the 9 being pulled out, and what's left over is the 5 and the 1. However, we got more stuff going on, right? I also have an x to the 3rd and an x to the 5th. So I can take away at most x to the 3rd from both of these. And if I take away an x to the 3rd, that means 2 of them are left over here. So I'll have an x squared. And then there is no z in this term, so that z has to stay. And there is no y in the first portion. And that is as far as I can take this one. And again, you can always redistribute your answer to figure out where you are. Well, what happens if I have more than 2 terms, something like this? Well, now we go back to, some people like to think of the box method, but we can make our life a little bit easier here because all of these values can be divided by -2, and they all share an x. So I'm going to take out what we call a common monomial term first. And when I do that, I get an x squared left over for this part. I get minus 15 x left over here, and then I get a positive 26 left over here. Okay? So now the question is, and if you're not sure on that, if the signs don't make sense, redistribute what we just took out. Did you get back where you started? And then I have to decide, can I factor this any further? And are there any factors of 26 that add up to give me negative 15? And that goes back to if you wanted to do the box with the circle in it for this extra portion here, you could. But I don't think we need to because I know negative 13 times negative 2 gives me a positive 26 and adds up to give me a negative 15x. So this is something that they expect that you can do completely and you really understand how to factor all of these pieces. This is a skill that I end up reteaching this quite a bit in calculus. So we're hoping you guys connect with it today. All right. Don't write this one either, but what about just conceptually, what are we thinking? Okay, so what if I have 10 Anna squared times Ames minus 4 Anna, and I tell you to factor? I've got two pieces, right? I've got this piece, and they're separated by subtraction. So I want to think, what do they both have in common? Well, let's look at 10. 10 is 2 times 5, and 4 is 2 times 2, so I can pull a 2 out. And then what do they also have in common? They have 1 Anna in common. And what's left over is if the 2 is out, and I've got a 5, I'm not going to have enough room to get this in. So if I take away an Anna from this side, that means 1 Anna is left over. There is no Ames over here, so we're going to have another Ames. So 5 Anna Ames. And again, if you times by 2 Anna, you would get back right where you started. And then if I take away a 2 Anna from this, all that's left over is the minus 2, because Anna is factored out. So that's as far as I can take that one. And then same thing here. Notice we got two pieces. Right? I have Allie squared times Jordan minus 9 Jordan. Well, they both have Jordan in common. So what's left over is an Allie squared minus 9, because I took the Jordans out. Now this is a little tricky. If you really want to think of this as an x, right? Think of Allie as an x. Well, wait a minute. If that's the case, then we can actually split this up because Allie minus 3 times Allie plus 3, negative 3 times negative 3 add up to give me the 0 missing term, but negative 3 times positive 3 gives me negative 9, and Allie times Allie gives me Allie squared. So if you didn't like that, if you're like, oh, I don't like that, think of it as x squared minus 9, and then it would be x minus 3 and x plus 3. And that's called the difference of squares. So you can always think of this in terms of x's if you need to. All right, so we're going to go one more breakout room. I'm going to share a different slide, and your goal is to work through this one kind of the same way we did that, the other one, except for the only difference is now we've got just factoring. So factor each of the following. There's 10 questions on this one. I will put you in the same breakout room, and then I'm going to give you the new worksheet here in the chat. But I will also, once you get into the breakout room, I'll also put this in the message to the chat. So you can go back, back to your breakout room. So for number 1, we have a dog in common, so we'll factor out the dog. We're left with cat plus 5. For number 2, you could think of this as 9x squared minus 25. And then you're thinking, what are the factors of 9? Well, that's 3x and 3x. And then what are the factors of negative 25? The key is that it's negative. This would not work if it was a positive. But this expression factored is the same as if I had 9 squared minus 25. So that's what we call the difference of squares. Okay. Same thing with number 3. If you really wanted to think of it, you could think of it as x squared plus 11x plus 18. And then what would that be? It would be x plus 2, x plus 9. Factors of 18 that add up to 11 are 2 and 9. So you can kind of think of it that way. In this case, it doesn't work as well because we have variables mixed together. So when I look at this, I'm thinking, what do they have in common? They each have at least one tree and one leg in common. So I'm going to factor that out. And what's left over is 3 plus 2 tree. Okay. And then here, the only thing we can take away is a number, right? Negative 3. Now, I like to pull out the negative here. So this first answer is kind of what I would prefer because I like things not to have a negative at the start. However, you could have just factored out a 3 and got the same answer. The only difference is the sign change of what's in the parentheses. Okay. And then here, 24 and 56, the greatest factor that goes into each one of those is 8. And they each have at least a star to the third power in common. And what will be left over is 3 star minus 7. Okay. And then number 7, I would take out a negative. I like to take a negative because that's definitely both in common. Even if this one was positive, I think I would still take a negative out. But I get negative 7 triangle times 7 minus triangle squared. If you redistribute, you should get back to where you started. Okay. Number 8, 4 blue red times blue squared plus red squared. And we're kind of getting into the whole reason here. Z, you got a question? I just saw your chat.
Yeah, I do.
Which one?
Number 4.
Oh, okay. What's
So my question is, since that one is like, since the tree is like cubed on the other side and it's like just 1 on the other side, isn't there gonna be like a square? I don't know.
Yeah, no, you're right. Let's check because I did it as if this was a squared. This should be a good catch. That should be a squared right there because this
Okay.
originally was a 3. Thank you for that. Good catch.
Cool.
Look at number 9. 9 is really interesting, and I'll give you a hint. The whole reason why we're doing this is because of a question like number 9. Now, we could think of it as x squared plus 6x plus 8, and we're thinking, what are the factors of 8 that add up to give me 6? Well, that's 2 and 4. And then instead of x times x, it's cosine that's going to be in that spot. And that is what we're going to be dealing with on Friday this week. So I think number 9, we snuck that in there, but you'll see how number 9 comes into play later on. All right, and then the last one, we've got each one of these has a 2 life squared in common. So I factor that out first. That's called a common monomial term. And then what's left over, if you want to think of it as x squared minus 13x plus 12. And I'm thinking, what are the factors of positive 12 that add up to give me negative 13? It's negative 1 and negative 12. And instead of putting x, we put life. So just to get you to think about the properties, we kind of made things a little more interesting today. Now, your homework tonight is on delta math. I want to make sure everybody understands what's at stake here. So we only have a couple of weeks left in the trimester. We have this week and where's my calendar? We got this week, which was 5 days. Next week is 4 days, and the week after that is 4 days, and then the week after that is 2 days. So we really don't have a lot of time. And if you want to improve your grade, you need to get all your homework in that's missing. And you want to do the chapter, the Delta Math tonight is 5.0 fractions and factoring. This is going to be friendly numbers. It's not going to be kind of like the trees and the squares and the circles like we did today. All right. Do you need to complete the chapter 4 test remediation? Some of you, you didn't even turn in your work for your Unit 4 test, and that was worth 7 points. So if that was one of you, you can go on campus, and I put a comment in there, did not turn in work worth 7 points. If you have that work, submit it to me so I can give you the credit for that, or submit it to Schoology so you can get those points. If the test didn't go great for you, you can do a remediation. Remember that remediation is just going back to the optional Delta Math Chapter 4 review and doing every problem on it. And then when you're done, email me and I'll boost your grade to a 70% for that test. Okay? This is the last unit of the trimester. We're going to do a modified version of Chapter 5. And we're going to actually do it halfway, and then we're going to pick up the other half for third trimester. So think of it as like a mini 3-week unit or so. All right, that's all I got. If you have any questions, stop in and see me in my office hours today from 1 to 2. Have a good day.